Hi everyone, today we're going to be learning about the product rule, which is used in the derivatives. So let's say we have a function px, which equals to fx times gx. So you might assume that p prime x would be f prime x times g prime x. However, this assumption is wrong, and I can prove it to you why. So let's say that fx would be x squared plus 1 and gx would be x plus 2. Now we can find px by opening the brackets and expanding the equation. So px would be x squared plus 1 times x plus 2. The expanded version would be x cubed times 2x squared plus x plus 2. So we can differentiate the function and we'll get 3x squared plus 4x plus 1. Now let's try to test that with our assumption. We can find f prime x, which would be 2x, and g prime x, which would be 1. So 2x times 1 would be still 2x. And as you can see, this equation and this equation are not the same, hence our assumption is wrong. However, there is a formula to this. So if px would be fx times gx, p prime x would be f prime x times gx plus fx times g prime x. So let's solve some questions together. Let's say that fx would be x squared minus 2 times x plus 10. And we have to find f prime x. So we can apply the rule that was mentioned earlier. F prime x would be x squared minus 2 prime times x plus 10 plus x squared minus 2 times x plus 10 prime. Now we do our differentiation accordingly. So it would be 2x times x plus 10 plus x squared minus 2 times 1. And now we combine the equation, we get 2x squared plus 20x plus x squared minus 2, and simplified we get 3x squared plus 20x plus 2. Alright, now let's try a different question where we apply the product rule. Determine points where tangent to the curve y equals to 3 times x minus 5, x plus 2 is horizontal. So first we find the derivative of the equation, but as you can see there are two brackets, so we'll have to apply the product rule to it. So dy over dx would be 3 bracket x minus 5 prime times x plus 2 plus x minus 5 times x plus 2 prime, in which it would be 3 1 times x plus 2 plus x minus 5 times 1. And if you simplify, it will be 3 2x minus 3, in which the equation would be 6x minus 9. Now that we have the equation of the tangent, we have to find the horizontal tangent. So in the horizontal tangent, the derivative would equal to 0. So 6x minus 9 would equal to 0. And x would be 3 over 2. Now we substitute the x value, which is 3 over 2, into the original equation. So y times 3 over 2 would be negative 147 over 4. Thus, your point where the tangent is horizontal would be 3 over 2 negative 147 over 4.